This is assignment 10, number 2, problem 52, and the directions are to graph the parabola and find the vertex, the focus, and the directrix. So we are going to graph this. X squared minus 4x equals 2y, and we need to change it to standard form. So I'm going to start with just rewriting it over here, x squared minus 4x, and then put in a blank for completing the square is equal to 2y plus blank. So then half of negative 4 is 2, and 2 squared is 4, so in the blank goes 4. And then this side is x minus 2 squared is equal to 2 times y plus 2. So then the vertex is at positive 2, negative 2, and the standard form would have a 4a where the 2 is. So if I want to know what a is, I just write, well, 4a must be equal to 2. So a is equal to 2/4 or 1/2. So then that tells me that the focus is a half a unit away from the vertex. Now, since this parabola is an x squared parabola with a positive value, I know that it opens up. So I'm going to come over here and start graphing it. Over 2 and down 2, and that is the vertex. And then up a half of a unit from there is the focus. And then remember that the lattice rectum points are 2a away from the focus. So if the focus length is 1/2, double that is 1. So 2 other points on the parabola are over left and right 1 from there. So this parabola just looks something like this. Now, if you needed it to be more accurate, you could plug in some other points, but generally plotting the vertex, the lattice rectum points, and showing where the focus is all you need to do. I think we should give the coordinates of the focus, though. Oh, and we need to do the directrix too. So the focus is over 2, and instead of being down 2, it's only down 1.5. Now the directrix is a line that's on the other side of the vertex from the focus, and it's the same distance away. So since this distance here is 1/2, then the distance to the directrix is also 1/2. So I need a line that goes horizontally down a half unit from the focus. So I'm going to draw a line that starts, we'll say about right here, and go across, and that'll be the focus, the directrix. So the equation of that line to give the equation of the directrix for complete work here is a horizontal line down 2.5. So either down negative 2.5 or negative 5/2 would be fine. This is problem 35, and the problem says that the focus is at negative 3, negative 2. The origin is here, so 1, 2, 3, negative 2, and the directrix is the vertical line x equal 1. So you can tell then that the vertex must be right here at negative 1, negative 2, because it has to be an equal distance between the vertex and between the focus and the directrix. So the vertex is at over negative 1, down 2. So the a value is the distance between the focus and the vertex, and that is 2. The equation is going to be of the form y squared squared equals negative 4ax, because the parabola must be cupping around the focus, and so it's a y squared sideways parabola, and a negative because it's opening toward the left. Now it has a shift to it, so it will really be y plus 2, the opposite of this minus 2, squared, equal to negative 4 times 2 times x plus 1. And just cleaning that up, y plus 2 squared is equal to negative 8 parenthesis x plus 1. So that's the problem. You just had to find the equation. And you can plot the latus rectum if you want to get a good sketch of it. You could go up 1, 2, 3, 4. That's double the distance from the vertex to the focus, which this is 2, so then this is 4, and down 1, 2, 3, 4. And then if I draw that parabola, it looks something like this. So there you go. Good luck.